the fence, books and pens. I can tell that we are gonna be friends.
This is 5 questions, and for this one what we're going to do is we're going to focus primarily on trigonometric graphs, sine, cosine, secant, cosecant, tangent, and cotangent. Let's get to our first one here. Our first one is like a multiple choice problem. What you're going to do is you're going to have to figure out which of these 3 graphs represent the cosine with this restricted domain, meaning I'm just simply giving you part of the graph. In order to figure that out, you'll want to first recall what the fundamental period for the cosine, what it looks like. Recall that for y equals cosine x, the period is just simply 2 pi, which means that we're going to get this u shape every 2 pi units. So if you were to add another u shape, it would end at 4 pi. That's the meaning for the period being 2 pi. If you add another 2 pi, we get to the end. So if you add another 2 pi, that means we get another u shape. And then another u shape. Okay, so let's examine here. You'll notice that from 7 pi to 8 pi, we go from bottom to top. So we want to look for that little pattern from 7 to 8 pi. We don't see that here or here, but we do see it in the first one. Therefore, this first one is the correct graph. For the second one, what you are to do is you are to determine the value of this particular x-coordinate right here. What you have here is what looks to be a sine wave, so hopefully you recognize the equation for this. Typically, this represents the amplitude, which is not very important here. You know that this is at the most extreme point, and because of the y value being -1, we know the value of a. It's 1. This here is of more importance because of the fact that h is a horizontal variable. We want to know how far across we're going, and the period impacts horizontal. Typically, when you want the period, what you would do is you would take 2 pi and then divide by the the coefficient of x. Well, in this case, hopefully you recognize there's a little 1 here. So what we're looking at is 1/8. So the coefficient of x is 1/8, and that's what you're going to be dividing into 2 pi with. If you divide that, recall that to divide a fraction, you're actually multiplying by the reciprocal. So what we should get is 16 pi. That means at the very end of the sine wave, 16 pi units is where the graph starts to repeat itself. Let's put some tick marks here. And here you'll notice this is the end. This is where we start at 0, therefore we start going up again. When we reach 0, we know we've reached the end. So therefore, what's this unit? This is the one we're really interested in. Well, if you wanted the first increment, you would simply figure out that it's 1/4 of the way to the period. So 1/4 of 16 pi would give you this mark. 1/2 of the way would give you this mark. 3/4 of the way would give you this mark, which is the one we want. So it's 3/4 of the period, 3/4 of 16 pi. This, by the way, does reduce. This gives us 4/1. So therefore, 3 times 4 pi is 12 pi. And that's essentially your answer, because you would have had to have gone across 12 pi units first and then gone down 1 unit to get to this location. Since it's just the x value you're interested in, that's all you want. Let's do another one that's similar. Hopefully you recognize this as a tangent graph. Remember that since this involves the horizontal component, you're going to focus more on this guy more than a, the amplitude. For the period, you're going to be dividing again, except you're going to divide it into pi instead of 2 pi. The reason being is because for the tangent function, the ordinary tan function repeats every pi units. Thus, it's pi/2 being divided into pi because that's the coefficient of x. Recall that if you're dividing by a fraction, this fraction you would flip it over and then you would multiply by that reciprocal. So it's pi times 2 over pi. These go away, and you get 2. Keep in mind that the fundamental period basically ends right where you started. So if you started at 0, you're going to finish at 0. So at this point, this is where it begins to climb again. That is where your 2 goes. Let's put some tick marks here. The asymptote typically is the halfway point in this, so halfway between that and 0 will get us to where we want right there. So halfway there, that's 1. And halfway here between 0 and 1 is 1/2. So that's really all we're interested in there. This 1 here that I've just put, this refers to the fact that the y value is 1. So you go across 1/2, you go up 1. That's really your answer. Okay, determine the amplitude and period of a sine wave that's already graphed. And here it is. You'll notice that we don't have the complete sine wave here, so we're going to have to kind of use some intuition. Recall what the fundamental period looks like. It's a complete S shape, so that when we get to the end of this, that's where it starts to repeat itself. So we know that right there will be the period. We also know that from the start all the way to the top is going to be the amplitude. So if you're thinking the amplitude is 2, you're not thinking about the whole picture. Perhaps it would be better if we figured out exactly where the starting point is, so that it would essentially be cut in half. That's where it's cut in half, right there. It doesn't cut in half right here at the axis, but rather down here at -1. We know that because the high is 2, and the low is way down here, which is at -4. You also have to keep in mind that the amplitude is going to be the same distance going up as it is going down. So if you look at it that way, the distance from here to the top, being the same as it is to the bottom, is 3. There's also a formula that you could use. The formula, and by the way, I'm not advocating memorizing this formula. The formula is useful if you don't have a graph, but if you do have a graph, just simply count. Basically what you do is you take the high and the low, and you subtract one from the other. Because the high number always goes first, this value will never end up being negative. The high is 2, the low is -4. So 2 minus -4, then divide by 2, and we'd get 3 again. Now let's turn our attention to the period. Recall that the sine wave reaches the halfway point right here, where it crosses that 0 point, that starting point. So you'll notice that we kind of have that from here to here. That's the halfway point. So what we want to do now is figure out what the half point is, since we don't have the whole graph. We figure out the halfway point, we can double it, and then get the rest for the period. So let's look at what we've got. 2 units across is pi. If you go another 2 units, you get 2 pi. Thus, you can probably figure out what another 2 units is. So at 3 pi, that's where we essentially get halfway through the sine wave. If that's halfway, then that means when this thing kind of trickles back up, this value here should be double. Therefore, our period is 6 pi. Okay, one last one. We want to graph one period of a secant. The secant, you'll recall, has a reciprocal for cosine. So let's focus on the cosine graph first. Let's look at this without all the plussing and minusing going on. So we won't look at this part over here. First, focus on the amplitude. The amplitude is 2, which means it's going to go as high as 2 units and as low as -2 units. As for the period, The period is going to be 2 pi divided by 1/2. Now, when you divide by 1/2, remember that's the same thing as multiplying by the reciprocal. So what we get for that is 4 pi. So on the fourth mark, put 4 pi. And while we're at it, why don't we put in the cosine wave? Okay, I put a dashed line through the middle, by the way, just to kind of mark where the center of the wave is, or its axis. Let's try and figure out these other increments. If this is 4 pi, this will be 1/4 of 4 pi, and then 2/4, then 3/4. Okay, now that we've done that, let's focus on the translation part of it. To figure out the horizontal translation, whatever is trapped in your parentheses here, we're going to set that equal to 0 and solve for x. So that's x plus pi is equal to 0, and you get negative pi. Now, here's where the advantage of labeling all these marks. Pi, you'll notice, is just 1 unit over to the right. Because of the minus sign, what that means is that we're going to take this entire graph here, and we're going to move it 1 unit to the left. In addition, we have this value outside. That tells us that we're also going to be moving this down 1 unit. So take your cosine graph and move it over pi units. So there we are, and then down 1. And you'll notice that I'm also kind of dragging along this axis so that you can see where the middle of the wave is. You'll notice the middle of the wave is at -1, which is synonymous with the vertical shift. So the vertical shift always will tell you where this thing cuts in half. And that's going to matter for the next part, which is the secant. For the secant, it's basically building upon the cosine graph. So what you'll want to do is you'll want to keep in mind that all the cosine values, or rather all the y values, they end up flipping over. So essentially what it is this. You get this part of the graph, and it's going to flip downward. And this part of the graph is going to flip upward. Same thing here. It's going to flip upward. Before we do that, let's first put in the asymptotes. You will get one asymptote here because this is where the cosine wave is essentially being cut in half. So right where it hits right here at this axis of wave, that's where your asymptote goes. So we should get another one here on the y-axis. And again, from every bottom here, you're going to be trailing downward, and this actually goes towards our asymptote but does not cross. And at every peak, we are curling upward. Now, I'm not going to continue this, but if we were to continue it, this would simply curl up, and then you'd have your asymptote here on this side. Same thing over here at this peak, going upward. And we go towards the asymptote. The asymptote simply marks where the graph is tending. Now this cosine is not really part of the graph, so what I'm going to do is I'm going to fade that. And then now you can see what the graph is really supposed to look like. If you're showing your work, you can go ahead and fade it, but the way you'd show your work is to show that this is slightly there, and on your paper what you would do is you would have this be a dotted line. But again, remember, we use it as a guide to help us with the graph, but technically it isn't there.
We sit side by side in every class.
That's it for this one.
Teacher thinks
I'll
that
see
I
you next
sound
time.